Okay, so we're on page 15 and part 2 right at the top. So why is there an explosion? So suggest why waves are reflected from the oil field. It's because as you go deep underground, there are things of different density. That's supposed to say density, if you can read it or not. And therefore the waves will get reflected and refracted because there's different densities. Now here's a maths question, okay, D. And this is actually something that I now teach it based on one of the students who is now in year 11, but she was in year 9, and she was in year 9, yeah, obviously, and it's called Andreas Method. I teach it the whole school this method now, and it's really, really good. It's a foolproof way of getting things right. The first thing to do is just to write down what information you've got. So you've got frequency, which is 15 hertz. So I'll write frequency 15 hertz. Then you've got wavelength, it's 125 meters. So I've written wavelength is 125 meters. And the question says calculate the speed of the wave. So I've wrote speed and a question mark because I don't know what it is. Now you're going to go back to the front of the book and find a formula which has frequency, wavelength and wave speed. And what you'll find is that formula is this one here. Wave speed is equal to frequency times wavelength. Put in your frequency, multiply it by your wavelength, and that will be your wave speed. And because of course you know the units, it's 1875 meters per second. So that's why it's important to know what units belong to what, so that you know that hertz is measured in frequency, so that's your frequency, even though they've told you here, but it's best to know anyway. Wavelength is meters, so that's wavelength, and they want you to calculate wave speed, so that's your question mark. You go back to the front, look at the equation, put your numbers underneath, bam, you got your answer. I'll see you on the next page. Answer the questions. So this question up here says, which is the biggest? The biggest thing is the universe, of course. The galaxy. So within our current universe, it would be the universe, galaxy, and solar system. Nebula has to do with the life cycle of a star, so not too interested in that. Now, however, this one, it's got the stages of the life cycle of the sun, and I have made an acronym to remember the stages of the sun. And it's, if you think about it, no people are allowed in space, so it starts like that. That's my kind of keyword for the life cycle of the sun. So no people allowed. Red giant shall win decisively. And so it's nebula, protostar, average star, red giant, shell of gas, and white dwarf. So looking at this, we should be able to put them in order. So you should be able to do that. And that is what you should have had. Now, with the bottom one, you should be able to name all of these because, of course, raging Martians invaded Venus using X-ray guns. So it's radio waves, microwaves, infrared, visible light, using is ultraviolet, X-rays, and gamma rays. Okay, nice and easy questions there. This paper is actually quite easy. P1, guys, you should be smashing. Okay, so this question says, explain why some telescopes are located outside the Earth's atmosphere. It's because some of the rays, the electromagnetic spectrum, would be absorbed by the Earth's atmosphere. So if you place those telescopes on Earth, it can't get through to that telescope because the atmosphere above is going to absorb it. So let me draw a picture. So if this is the atmosphere, right, and this is my ray, my electromagnetic spectrum coming in, and I've got the Earth, and on the Earth I've got my telescope. Now if that electromagnetic spectrum gets absorbed by the atmosphere, none of it's going to reach the telescope, and that's not good. So what they do, instead of putting it here, they put it above the atmosphere, so that whatever rays are coming in will be picked up above the atmosphere. And so that's the explanation of this question here. Now this 6 marker, I'll just point out how modern telescopes have contributed to the understanding of our universe. You can really talk about 3 main points, and you'd have to talk about it in, like, obviously with explanation. I've just done it as a bullet point. Number 1 is the improvement of technology versus seeing things with your naked eye. So obviously that's a big improvement. Detective invisible electromagnetic spectrum. So in other words, before we would just use visible light to see with basic telescopes. Now you've got different types of telescopes that can see different parts of the electromagnetic spectrum: X-rays, gamma rays, radio waves, and microwaves, and any other type of waves that can be detected. And the other thing is the positions at which those telescopes can be placed. So you can place some on the Earth, as we said, and so there are some that can go through the atmosphere. So if it can go through the atmosphere, you can place them on Earth. But if they can't go through the atmosphere and they get absorbed by the atmosphere, then you can place the telescope above the atmosphere. So that all helps to contribute towards our understanding of, help me out, what's the question, of the universe. Okay, so ice cream van playing in the background, lively day today, the sun is out. And we're on to this question. So again, I'm using Andreas Method, very good method. I'm reading this question and I'm getting the information out of it. So I've got an ammeter, which by the way measures current, and it's given me 1.5 amps. I've got a voltmeter that's giving me 6 volts, and they want me to calculate the power. So ammeter, 1.5 amps, got it straight from the question. Voltmeter gives me 6 volts. Power is missing. You go back to the beginning of your exam, you look for the formula that has these three in, and you'll see that its power equals voltage times current. The power is equal to 1.5 amps times 6 volts, so power is equal to 9 watts. Okay, and the bottom question, this is what my 6-year-old daughter has taught you guys and my 9-year-old nephew. Check the video out if you haven't seen it. It says state 2 changes to the design of the generator that would give a larger output power for the same speed of a rotation. So the speed is not changing, they said. They don't want you to change the speed. So you could have a stronger magnet here. You could have more coils of wire, or the core could be made from iron. Okay, and that would give you more power. Okay, so that's cool. Brilliant. Right, so this question is asking the difference between AC and DC current. DC current basically moves in one direction only, and AC current it changes direction, so it goes backwards and forwards in 2 directions. Okay, but changes direction is fine. Now this next 6-mark question is basically asking for the advantages of AC versus DC and the modern national grid. So before, I'm just going to speak this out instead of writing it. Okay, so before, what we had was basically a lot of power would be lost because DC cables, in fact I'll write this out, I'll be right back because it's important. Okay. So okay, anyway, here DC electricity, you would lose lots of power. The reason is because you couldn't change the voltage or the current, and it would generally have a high current. Now if you've got high current moving in your wires, it's going to produce a lot of heat, so you're going to lose a lot of energy through heat loss. Whereas with this AC national grid system that we have nowadays, what we can do is we can change the amount of current using step up and step down transformers. So if you've got less current, you're going to have less heat loss, right? Which is good. So you're saving energy, you're making the system more efficient when you're transferring that energy. Also, another difference is that before you had the cable, so in this old system you had the cables underground. Now you can see the cables above ground, so they're easier to change, easier to maintain if you need to change anything or maintain the wires. And like I said, these step up and step down transformers can change the current, so you can have less current when you need it or more current when you need to supply it. And obviously the other advantage within the text you can see is that this old system, you couldn't take the electricity very far. It was just to nearby houses for electric lights, whereas with this one you can take it literally across the whole country. So that's the answer to that question. And that's the end of this paper. This paper was March 2013.